thanks for the presentation, inviting us for presenting on this exciting study that we did or we are conducting right now for CAPCOG. I had come to this group, I don't know, probably over a year ago to showcase some of the benefits of like looking at monitoring at TTI. We do emissions inventories for all mobile sources from marine, airport, rail, and on-road as well. And then as part of that work, we do activity data and also emissions monitoring as well, and air quality monitors as well. So we do all kinds of work, and this is very exciting for us. This gives us a little bit of information of how the travel patterns are in the Austin, Austin MSA. So as part of this project, we were looking at telematic monitoring devices. We were wanting to assist the CAPCOG with the telemonitoring devices for the local governments that don't have them. At the same time, the ones that already have this information, we were going to collect it for over a period of 1 year or more, depending on what they have handy, and develop emissions and activity for each vehicle moving in the region, and look at like the spatial and temporal profiles of this data and analyze like where the maximum amount of emissions are happening in the region. And at the end of the day, I think the result of this can serve as recommendations for reducing emissions. So that was the idea. And on the right side, we look at these areas. All the 5 counties from the Austin area that we are, cities at least, working through Anton. We're trying to collect the data from them. So the big part of the project was to develop this pipeline or a framework, like a better word. So we wanted to get the fleet data, look out there if the data is complete, clean the data, and assign it to different roadway types, and then run our emissions model, which is the EPA's MOVES model, which is what we are required to use for emissions inventories. And this is the same model that we use for TCEQ SIP inventories and TxDOT work as well. So once we have those emission rates, we marry the activity and emission rates to get emissions inventories. And we look at these emissions and summarize it. Because we have this very disaggregated data, we can look at like, hey, which department has more emissions coming out, or where exactly in the Metroplex itself the emissions is happening. So all of that can be done, and whether it be idling or is it coming from running emissions or starts, what it is. So we can try to look at all of that and come up with some strategies. So for this work, I think our initial data that we got was from San Marcos. We got it for a month so that we can develop this pipeline. And we had a data for about 222 vehicles, which again reciprocates to 132,000 miles of travel in the region, which was really good amount of data. And then they also gave us some information on what kind of vehicles these were. And so we looked and we teased it out. So out of those vehicles, we had 87 of them gasoline, and then the other ones were diesel vehicles. Sorry. And on the bottom, you'll see the heat map, which kind of shows like where the travel is happening. Even though there are some travel, most of the travel was happening in San Marcos area, but there was some travel that was happening away from the city boundary itself. And one thing that we wanted to point out, that the data does not identify any personal identifiers, so that it's masked and we don't know who was driving or what it is. We're just looking purely on the vehicles that are being traveling in the region. Here's a quick fleet data, basic statistics of what the data looks like. And I don't want to go through everything, but I just want to highlight a few things. So here there is a 1993 vehicles. If you look at the animal shelter, they have only one vehicle, and they have a 1993. And most of us know that if the fleet is older, they emit more. So that's the case over here. They only have one. They're using it at 406 miles, which is not that big, but yeah, just to point that out. And the majority of the vehicles are in the water department. There are 32 vehicles, and they drive at an average of 15.4 miles and 22,000 miles a year, which is also not that good compared to 16,000 miles per vehicle. So that's something that we can live with, I guess. But this again gives you a statistics of what the travel is and how much distance they travel per fleet and what is the average model year of these departments. So most of the fleet, I think the good news is at least the city of San Marcos have 20 plus model year vehicles fairly new, but there are some departments that have like older vehicles which are older than 25 years old. So that is a point that to make that the more we kind of get rid of these old vehicles, the emission reductions will be much higher. So once we have cleaned up all the data and looked at everything, so we wanted to assign the roadways. For us, the roadway is important because these emission rates change at different roads. Emission patterns, I mean, because you're at a cruising speed on I-35, I mean, at some stretches, so you would have lower emissions, whereas your stop and go traffic might have higher emissions. So based on that, we have to apply the emission rates. So we took the lat and longs that we received and geocoded that to the roadway types. And the ones that we did not find a good match, we assigned them to urban restricted. So you can see that most of the travel is happening on urban and restricted roadways in these counties. And finally, on the emission calculation side, as I said, we used MOVES 5. And this is the latest and greatest model that is out by EPA. And we have developed this at a county scale for Hays County and developed emission rates for running, idling, and starts. For all of these are important for us because we can identify in a couple of slides. I'll show you like why it is important to look at these in different profiles, emission profiles. And finally, for each trajectory, as it is moving from one point to another point, we estimate the emissions for these different profiles. Here's a quick breakdown of the activity itself and the emissions, total breakdown of activity and emissions. So if you look at the total emissions, it's approximately 1,200 pounds per month for the month of September that we got the data, and VOC is 208 pounds per month. And if you look at the bottom table over here, majority of the emissions for NOx is coming from idle. So which means to say like the vehicles are idling at a location for a certain time, and that's their operation profile. And that is where the emissions are happening for NOx emissions. 770 pounds of emissions are coming, and for VOCs, it's running emissions at 54%. So that's a key thing. NOx emissions are higher during the idling, and that's something that we have noticed because they are running at a lower speed. They're very lower speed, and then all the controls are not running at a high temperature, so we won't get as much as benefit. And then we looked at it by fuel type, and we see that the diesel being the lean burn, we expect more emissions from NOx from diesel vehicles, and gasoline we expect VOCs as more. So that was typical, and that's something that we saw over here as well. But the part is like I think there's 76% of the NOx emissions are coming from diesel vehicles over here. And finally, breakdown by vehicle type. Due to the nature of the operations by different department, passenger trucks had more emissions compared to all other categories over here. And these categories were based on the VIN numbers that we got and some information on the vehicles. So we kind of had the database, so we mapped and we identified which were passenger cars and which were trucks. And there was all just one bus, I guess, in one of the departments. So other than that, most of the vehicles were either light duty commercial truck or passenger trucks. And finally, I think when the other thing that we looked at was the spatial distribution of the NOx. The distribution is similar to the NOx and VOCs over here, which is based on the emissions that are happening. So if you look at the at the running emissions, they are pretty much like majority of the emissions. I think you see the band, I think most of it will happen on the freeways and major arterials. And if you move to the starts, these are happening at the buildings, close to the buildings, City of San Marcos public buildings and Hayes County Municipal Building and City of San Marcos City Hall and Municipal. So they are happening at, which is typical because your starts are tend to happen over there. And then you have the idle emissions. So idle emissions is kind of sparse. So it is varied and it's spread throughout the region. So that's something that we've identified over here. And finally, I think the temporal distribution, again, this tends to show us like what time of the day these emissions are happening in the day. And we see that I think 7 a.m. And after lunch is when majority of the activities are happening. And some some vehicles, I guess, they operate overnight as well, depending on the service calls. So, which is typical for a city fleet. And that's something that we have seen over here. And VOCs is a slightly different than NOx. You still have the peak, and the majority of the peak is in the after a certain time. And this might be related to the temperature profiles or just the operating profiles as well. And finally, the breakdown of the results, I guess, by department. You'd see that as mentioned, I mean, there's 32 vehicles in the water department, and that's where majority of the emissions are coming from. And the second and third, I think you can look at the other 12.5% and 10.4% by the SME maintenance and power for NOx, and then you have traffic and water quality for VOCs again. So this is just a breakdown. And again, this is only 1 month. I just want to point that out. Like this is only 1 month of data that we have. And since we have set up this pipeline, we could, as and when the data comes in, we can run through the data and have emission profiles and emission summaries by, I mean, we can have the summaries by whatever aggregation that we need, and also look at a pinpoint like where exactly different profiles are happening, and try to see, like, also add time to it. So I think the sky is the limit when we get this data, and we want to just summarize in different ways that can help the cities to identify what strategies would be beneficial for reducing emissions. And by model year also we looked at it. Older vehicles, again, as I said in the earlier slide, that older vehicles tend to emit more, and they contribute higher. And in this case, I think when you look at the model year 2020 over here, the NOx and VOCs, majority of the NOx is 20. I mean, is coming from 2010 and older vehicles. So that's where the emissions are happening for NOx, and then VOCs are typically for gasoline vehicles. VOCs are higher, so you tend to see a little bit more when compared to diesel vehicles on it. So, and going back to what we are, again, this project ends, I think, in November of this year, is for us to get more city fleets and add to this pipeline. As of now, as I said, we only have San Marcos data for September 2024. We want to, as we get more cities, I think we can have a big picture of what's happening in the region itself, and also come up with like hotspots, where the hotspots are happening, comparative study between different departments, fuel type model year, spatiotemporal analysis. A lot of work can be done in terms of analytics and looking at how best we can tease this data out so that we can provide meaningful information to cities. And finally, I think cities can take this information and see like what recommendations are available, such as like have idle ordinances, or as the other speaker said, like their TERP money to reduce, kind of phase out the older vehicles in the fleet. So these are all options I think the cities can start looking into. With that, I think though that was a quick summary. I think this is just a preliminary data right now. As I said, we have other data coming in, and we'll come back again with much more comprehensive information to you all, and I think by the end of, probably by August or September of this year. And Ton, I think with that, I think we are available to answer any questions that you have, and we're also available if you want to. We'll share this slide with Anton, and you can follow up with any questions as well.
Great. So we're running low on time. We still got 2 more agenda items or 3 more agenda items to get to. So if there are any questions, feel free to enter them into the chat, and then we'll try to answer them via the chat or over email after the meeting. With that, I'll put in a plug that we are collecting data from a few other cities currently, and we're just working on how to get that over to TTI. But if there's any organizations that already have any kind of fleet monitoring data and would like to participate in the study and have this kind of, not like an audit, but I guess analysis of their fleet data completed, feel free to get in contact with me. That said, you need to have your devices already installed and have a fleet data logger already being in use, because I think we're a little bit late in the process to install any devices at this point. But our hope is that in the future years, we'll be able to continue this and do this at other cities or counties in the region. So stay tuned for more.